Okay, so do this. So at the top there, of course, MCs, multiple choice, vocab is the second part. There were and this is a very similar format to all my tests. So it'll be 3 sections like this. So I was thinking about vocab, and as long as you at least write the review terms down. Okay, in some cases, I could tell you put a lot of time into your cards. In other cases, your note cards you can bring with you. In other cases, not so much. So remember, you can bring a note card with you to the test. And even if you just put the review terms on your note card, that's going to help you. Okay? Okay, that's all I'm trying to say. So vocab section, 10 questions, each worth 2 points apiece. And then the last section, there were assortment of questions. They were either worth 3 or 6 points apiece. So there were actually 74 points you could have earned, and I took it out of 70. So the percentage you see, and this time I actually wrote it on your test. I don't always, but that percentage is what you see in the grade book. Okay. So the first one, a question about circumpolar stars. The best answer there is A, that circumpolar stars will always remain above your horizon. They aren't necessarily near Polaris. Question 2, the best answer is C. And actually, worth 1 point there, that question, the whole thing between weight and mass, I wish I would have put weight and mass on your review sheet. I didn't. But remember that your mass is always the same, and weight is actually kind of the force that you're feeling because of the object you're standing on. So in that context, C is the best answer, that your weight is going to be less on the moon than on the Earth, but you'll have the same mass. Question 3, there were 3 questions that I took an assortment of answers, and question 3 was one of them. I would take either A or C. I picked A at first, but notice that actually C is the correct answer. How fast you're going to be falling after you fall in 3 seconds from a building, assuming that there's no air resistance involved, you're going to go faster. The first second you're going to go 10 meters per second. The second you'll be going 20. The third second you'll be going 30, but the units will be meters per second, not meters per second squared. So I hand-checked everybody's. Question 4 was the whole kind of, I think, of the sailors out there. They use basically the local sky. They find Polaris, and they put their hand out to the horizon, and they put their hand to Polaris, and then that is what we call the altitude in their local sky, and that's the same as the sailor's latitude. So question 5, the speed. And this is, I would take A, B, or C for this one. I just decided it wasn't a very good question. It's asking you which of Newton's laws is represented by basically taking a pull cue and hitting a ball. And I think a case could probably be made for all of his laws. So I'd take any 3. Now, when I pull questions for my final here, that's number 5's not going to make it. If it was that confusing, it's definitely not going to make it. Question 6. The universal, the law of gravitational, universal law of gravitation is this. And basically, I asked you what is the D term, or actually how the distance affects the force of gravity. And basically, B, that if you increase the distance between the 2 objects, B, the force will decrease. Let's see. The next page. So 7, you experience nighttime. The best answer there is C, as the side of the Earth that you're standing on or occupying is facing away from the sun. Question 8, what's the acceleration due to gravity at the Earth's surface? And that's about 10 or 9.8. And the big thing here is you needed to get the right units. So it's meters per second squared. Downward. Question 9, what causes the apparent retrograde of the motion? The best answer there is B, that Earth is actually passing that planet in orbit, okay? But the planet's motion isn't really changing, so B is the best answer there. Question 10, planets never travel in a straight line, and according to Newton's second law, this means that actually there must be some sort of force acting on them to cause this acceleration. Remember, acceleration can be either a change in the motion of direction or change in speed. So that's what I was after there. Question 11, in which of these are you not accelerating? And the only time you're not accelerating is if you're going a straight line at a constant speed, A. Question 12, if you take photons from that a galaxy is sending you, and that galaxy is 1 billion light years away, then you are looking at that galaxy as it was 1 billion years ago. I think that is so cool. Question 12, excuse me, so sweet C is the best answer for question 12. Question 13, basically kind of from close going out, what would be your cosmic address? C is the best answer. U, the Earth, our solar system. Then our star is a member of the Milky Way galaxy. Our galaxy is clustered with other galaxies called the local group. Our local group, or our supercluster, our cluster of galaxies are further clustered into what's called the local supercluster. I need to stay on that page, don't I? Question 14, tides. The best answer there is D. They have to do with gravity. Tides are created by the moon's gravity on the Earth's large bodies of water. Question 15, kind of from smallest to largest, to be planet, star, solar system, galaxy is the best answer for D. Question 16, Ptolemy, remember the geocentric model. He basically inserted those epicycles, circles upon circles, to explain the retrograde motion of planets is the best answer there. Question 17, why is it summer in the northern hemisphere when it's winter in the southern hemisphere? The best answer there is that D, the northern hemisphere is tilted toward the sun, and thus the sun's rays are more direct. Question 18, absolute zero is 0 Kelvin, A. Question 19, if an object's moving in a straight line at 50 miles per hour, according to Newton's first law, it's going to continue that motion, D, until acted upon by another force or by force. Question 20, which most of the mass in the Milky Way galaxy is located in the halo region, C. Question 21, why is Polaris so darn special right now? It actually appears to be very near our north celestial pole, A. Question 22, who discovered the moons around Jupiter? C, Galileo. Question 23, the fact that virtually every galaxy is moving away from us. The more distant the galaxy is, it's moving faster, suggests that C, the universe is expanding. Question 24, you're standing at 0 degrees latitude on the equator. You look for Polaris, and Polaris is going to be on the horizon due north. Question 25, which of these phases of the moon would you have low tides? Remember, these are phases of the moon where the sun is at a right angle from the moon. And so those are your quarters. So the best answer there is E. Question 26 was the whole dropping two objects clearly that way different and seeing which is going to, how they're going to fall. And if you remove the effective air resistance, they're going to fall at the same, accelerate at the same rate. So they should hit the ground at the same time. C is the best answer there. 27, which of these is true about the moon? It's true, D, to say that the moon's distance from the Earth will vary. That's the perigee and the apogee sort of thing. All the other things are not true about the moon. 3 more for the multiple choice. Question 28, who discovered that planets orbit the sun in a shape called ellipses? Of course, that's one of Kepler's laws, E. Question 29, has Polaris always been the North Star? The answer is no. We know Vega was the North Star maybe 13,000 years ago. And that's because of precession. So the best answer there is A. Okay. Question 30 was the third question that I would have taken either A or C, because to me they seem very similar. It says Kepler's second law that states that a planet moves around its orbit to sweep out equal areas in equal amounts of times means that at perihelion it's going faster than at aphelion. Okay, perihelion goes fast, aphelion it goes slow. Once it's closest to the sun it goes fast, when it's furthest from the sun it goes slow. So I really think A was kind of what I was most after there. C is actually, I think, kind of talking about what track it's on, and so I could see where you might get those kind of mixed up. So I would take either A or C for that. And so the vocab, the first one, I was after astronomical unit as the average distance between the Earth and the Sun. The ecliptic, or the plane of the ecliptic, is that path that's marked out by the Earth as it orbits the Sun. Celestial sphere is that model, that kind of imaginary ball with the Earth in the center. Kinetic energy is the energy that we specifically associate with something that is in motion, or with the motion of an object. So that was what I was after. Question 35, precession is kind of that slowing, I can see I have a typo there, like a slowing spinning top, kind of why Polaris hasn't always been our North Pole. Question 36, I would take either KISS or Occam's razor as kind of that hallmark of science that says the simplest the better, don't make it too complicated. Question 37, acceleration is by definition if an object is changing its velocity, and remember velocity has a speed and a direction component. Question 38, parallax is when you close your one eye and the other eye. Basically, you're kind of changing your point of view. There's a nearby object, which is your finger, and it looks like it's different positions against the background. Question 39, I was after momentum. Remember momentum, which is usually the symbol P, is the mass of that object times its velocity. And we kind of looked at maybe a bicycle and a Mack truck. They have different momentums. Question 40, what looks like hypnotize, but hypothesis is kind of that early on before it's came to become a theory. Right. There's definitely options or opportunities for partial credit here. But what I tried to do is it's just like your kids, like if you treat one like you treat the other. So I tried to kind of be across the board the same. But for the first one, I was after you to tell me that you recognize that there's a difference between light year and a year. Okay, it's true that the Big Bang goes back some 13 to 14 billion years ago. Okay, but it's not true. That's different than 13 to 14 billion light years. That's a distance. So that's kind of what I was after there. Question 42. It's kind of like a homework question, and what I was after there is for you to tell me that it takes light a certain amount of time to get from an object to us. Okay. Briefly explain why when you look at an object that's in the distance far away, we're actually looking back in time. That's kind of what I was after. There's a delay. Question 43, not only did you need to tell me would the Earth no longer have seasons if it didn't have a tilted axis, but you had to explain why or why not. So I really liked especially some of the answers I saw because it talked about if the Earth's axis of rotation weren't tilted as it orbited the Sun, the directness at any given latitude, the directness of the Sun's rays would be constant. So there would be no variation. Only reason there's variation is because of the tilt. That's kind of what I was after there. Question 44, why does the Milky Way appear to be kind of a band of, what did I say, a band of light in the sky? So I was kind of after something that Galileo saw, basically tiny little stars. What looks like dust is actually tiny little stars. And the reason they're tiny is not because they are tiny, but they're tiny because they're so far away. Question 45. This was, I thought this was kind of an interesting. We talked about, remember there was a figure in your textbook that had the sun, and it showed the path of the Earth, and then outside it showed the zodiac sign constellations. And so actually kind of as you think about that figure, that whole, if you take your hand and go like that, that's the plane of the ecliptic that holds the sun and the path of the Earth, okay? So those special zodiac constellations lie on the ecliptic. And that was the significance there. So constellations like the Big Bear that hold the Big Dipper, Ursa Major, okay, they are outside the ecliptic. So worth 3 points. The next one also, I was kind of particular because I wanted, not only do you see, if you're standing on the near side of the moon, okay, not only do you see the Earth, but I wanted you to kind of describe, if it's a lunar eclipse, what's so special about the Earth. And I even saw some people kind of drawing pictures. Here's my picture right here. Okay, what's so special about what you see? So if you're here during a lunar eclipse, the moon is passing into the Earth's shadow. So like you see in my answer key, basically you would see a solar eclipse. So the other two, 47 and 48, are pretty straightforward. The laws of motion, Newton's laws of motion and Kepler's laws of motion. Okay? So again, that answer key will be posted under doc sharing, that unit exam folder.